Good day everyone, and welcome to Harmful Algal Blooms in the HABble. Before we dive into what the HABble is, let's review what harmful algal blooms are. Algae are microscopic aquatic organisms that perform photosynthesis. For the most part, they are harmless, but some of them produce toxins which can harm organisms in the surrounding environment, including humans. Harmful algal blooms, or HABs, occur when algae that produce toxins grow excessively to the point of being visible. This happens due to warm temperatures and excessive nutrients from fertilizer or sewage. HABs can affect the economy as well. Fisheries can experience economic losses due to massive kills caused by algal blooms, and tourism can be affected by the look and health impact of these HABs. In terms of ecological impacts, blooms deplete oxygen levels in water, leading to dead zones where aquatic life cannot survive. The balance of marine ecosystems is altered, often resulting in the decline of certain species. Primary approaches to manage HABs in the Philippines include 2 chemical treatments and 1 biological control method. However, none of them have been implemented on a field scale in the Philippines, underscoring the need for further research and development. There are various methods developed for algae removal, but one particularly promising approach is the use of hydrodynamic methods such as low-pressure air flotation, or LPAF. LPAF is a process that uses microbubbles generated at low pressure to lift and remove algae from water. It has already been tested on a large scale, but we wanted to downsize this technology for more localized and cost-effective applications. With that, my team and I are delighted to introduce you to the HABble, our innovative small-scale Bangka designed to combat harmful algal blooms using low-pressure air flotation technology. Here's how it works. The Bangka will be navigated directly to areas with high concentrations of algae. Raw water is sucked in through a durable PVC or steel tube, which then flows into a fast-mixing section on board. In here, a coagulant, polyaluminum chloride, or PAC, is introduced from an overhead compartment. This coagulant causes algae to clump together and form larger aggregates called flocks. PAC was chosen following a study that successfully used it for the air flotation technology. It also reportedly offers many benefits, including simple preparation, high efficiency, minimal aluminum residual, and reduced impact on water pH. After the fast mixing section, which ensures that PAC comes into contact with a maximum number of algal cells, these flocks then move into the slow mixing section, allowing them to grow larger and more stable. Next, the water enters the microbubbling chamber. In here, incoming low-pressure air collides at high speeds on a collision plate, forming tiny microbubbles. These microbubbles attach to the algal flocks, causing them to float to the surface. An automatic skimmer then skims off these floating flocks. A moving screen, functioning like a conveyor belt, helps to further dewater the algal flocks and transport them to an algal tank for temporary storage. These flocks can be later disposed of or repurposed. The remaining water is then discharged back into the body of water through another tube. Fine meshes will be installed near the water outlet to ensure that no algal flocks return to the ocean or sea. This entire system is powered by a diesel generator and controlled via a control panel located at the captain's deck, allowing for efficient operation. The HABble has a rate of 520 milliliters per minute with a pressure of 1.5 kilograms force per square centimeter and a bubble size range of 0.03 to 0.11 millimeters for the microbubble generator. However, while the HABble has groundbreaking efficiency in removing harmful algal blooms, this system admittedly has its limitations. First, the system only allows smaller scale removal of algae. Also, the power source for the system could still be improved using portable generators or even connecting the entire system to the engine of the Bangka. And finally, although the HABble is a cheaper alternative, it still requires an investment to build. With further innovations, however, these limitations can be solved. For proper implementation of the HABble system in different locales, environmental and regulatory considerations must be observed and practiced. First, the correct processes should be done in applying for approval in the implementation of the project. And to make the system as widely used, fair prices must be implemented so that the major public can have access to the technology. There are also numerous benefits and advantages in using the HABble system to combat harmful algal blooms. First is streamlined construction. Because of the HABle's compact design and strategic material use and positioning, the system has become lightweight and ergonomic. It is also resistant to stressors such as corrosion, chemicals, high temperature, salt water, and ultraviolet rays. Second, it is an eco-friendly method which employs low to none harmful chemicals, employing only flotation and aeration, making it an eco-friendly approach with no secondary pollution produced. And finally, because of the HABle's indigenized design, its utilization of the local boat allows it to be more affordable, making it easier to purchase and assemble for the public and local government units. While the HABble is still in its first stages, we believe that it is a groundbreaking way of addressing harmful algal blooms that can be accessible to all. Remember, a future with no HABs is only a boat ride away.